Out in the vast, mysterious expanse of the cosmos, on alien worlds far beyond our own, exist forms of matter we can barely imagine. From crushing pressures beneath the surfaces of icy exoplanets to the strange chemistry of Neptune's frigid depths, the universe is teeming with exotic substances that challenge our understanding of physics and chemistry. But today, we're not traveling across light years of space to uncover these secrets. Instead, we're diving deep into the heart of a laboratory where scientists have just confirmed the existence of something truly extraordinary: plastic ice. Now, before you start picturing frozen shopping bags or bottled water turned solid, let's clarify. This isn't the kind of plastic you find in everyday life. Plastic ice is a bizarre and exotic state of water, a hybrid between solid ice and liquid water. It exists under conditions so extreme that it was once thought to be purely theoretical, a strange, in-between form of ice that could help explain the nature of distant ice giants like Neptune and Uranus, and even the frozen subsurface oceans of moons like Europa and Titan. The many faces of ice. To understand why plastic ice is such a big deal, we first need to talk about ice itself. Here on Earth, we're most familiar with a particular form called ice-I, that's ice-1H, which is the version we find in ice cubes, glaciers, and snowflakes. It has a hexagonal lattice structure, meaning its water molecules are neatly arranged in repeating patterns, much like the honeycomb cells in a beehive. But Earth's everyday ice is just one of many possible forms. Under high pressure, water molecules can rearrange into denser, more compact structures, and things start to get weird. For example, at around 20,000 times the atmospheric pressure we experience on Earth's surface, water transforms into ice-VII, a rare, dense, cubic form of ice. Ice-VII has even been found trapped inside diamonds that formed deep within Earth's mantle, making it one of the most extreme ice structures known to exist naturally on our planet. But what happens if we push things even further? What if we increase both the temperature and the pressure to even more extreme levels? The experiment that changed everything. That's exactly what a team of researchers, led by physicist Livia Bove, set out to explore. Using advanced experimental techniques at the Institut Langevin in France, they subjected water to staggering conditions: temperatures over 326 degrees Celsius, 619 degrees F, and pressures up to 60,000 bars. To put that into perspective, that's about 59,000 times Earth's atmospheric pressure at sea level, akin to the pressures found deep within ice giant planets or buried miles beneath an alien ocean. To observe how the water molecules behaved under these conditions, the scientists used a neutron beam, which allowed them to see the molecular structure without disturbing it. As the neutrons passed through the water, they gained or lost energy depending on how the molecules were moving. By measuring these tiny shifts, the researchers could reconstruct the motion and structure of the water molecules in real time. And what they found was astonishing. A new form of ice is born. At 177 degrees Celsius, 350 degrees F, and 30,000 bars, something entirely new emerged. A strange phase of ice that had never been directly observed before. This was it, plastic ice-VII, a substance that had been theorized for years but never confirmed. In this phase, the water molecules were locked into a solid cubic lattice, just like in normal ice. However, there was a crucial difference. Unlike conventional ice, where molecules stay frozen in place and only vibrate slightly, the molecules in plastic ice were rotating freely, almost as if they were still in a liquid state. Imagine an ice cube where the water molecules are rigidly arranged, yet constantly spinning in place, a paradoxical state, neither fully solid nor fully liquid. But there was another twist. These molecules weren't rotating smoothly like spinning planets. Instead, their movement was jerky and unpredictable, constantly breaking and reforming hydrogen bonds with their neighbors. It was like an endless molecular dance, full of quick pivots and fleeting connections, making plastic ice one of the most dynamic solid states ever observed. Why this discovery matters. So why does this matter? Why should we care about a strange new phase of ice found in a high-pressure lab? Because plastic ice-VII might help us unlock the secrets of planetary evolution. Scientists have long suspected that this exotic ice exists deep inside the icy moons of our solar system, like Europa, Ganymede, and Titan, where intense pressure and freezing temperatures dominate. If plastic ice is present in these alien oceans, it could play a crucial role in how nutrients, heat, and even potential life forms interact beneath the surface. On exoplanets, worlds orbiting distant stars, oceans may stretch thousands of kilometers deep, with plastic ice lurking at the very bottom. This could influence how energy and materials circulate between the seafloor and the upper ocean, which in turn could affect the conditions for life to emerge. Even here on Earth, this discovery might lead to new insights into material science, potentially inspiring the development of substances with unique structural and thermal properties. The future of plastic ice research. Now that plastic ice VII has been confirmed, the next step is to understand how it interacts with other materials, like salts and minerals. If plastic ice forms in alien oceans, could it trap dissolved salts the way normal ice does? Or would its unique structure allow for better chemical exchange, making these oceans more hospitable for life? These are questions that planetary scientists, chemists, and astrobiologists are eager to explore. A universe full of surprises. This discovery is yet another reminder that the universe is far stranger and more complex than we ever imagined. Even something as seemingly simple as water, one of the most common molecules in the cosmos, can behave in ways that defy our expectations when placed under extreme conditions. From the crushing depths of ice giants to the subsurface seas of distant moons, plastic ice may be quietly shaping the evolution of planets right now, playing a hidden but crucial role in the history of our solar system and beyond. And as we continue to push the boundaries of exploration, both in the lab and in space, we're reminded that the most extraordinary discoveries aren't always light years away. Sometimes, they're waiting right here on Earth, just beneath the surface of what we thought we knew.